Hi there guys, and welcome to this question which has just been sent in about logarithms. So the question says find the equation of the tangent to the curve at A. So this is the equation that's being referred to, this which has been given to us in the question, and this is the coordinates. These are the coordinates at A which also have been given to us. So how can we find the tangent? Well, to answer any question, we really must break it down and go back to the basics. So recall that a tangent is effectively a straight line that touches the curve just once. So it could touch, for example, a curve like this, which is an exponential curve, just once. Okay, or it could touch a circle just once. That's what a tangent is. So a tangent is effectively, in this case, it is a gradient at this particular junction, at this particular point. It is the gradient which touches this curve just once. So, and from our A-level maths, A-level calculus, we know that the gradient can be worked out using, we can work it out using the formula n equals y2 minus y1 over x2 minus x1. But this becomes typically cumbersome when you have a curve that is changing at all points. So a better and more useful application here is to use what we call gradient. So gradient, what we call differentiation. So differentiation. Okay. All right. And we know if we have an equation, if we go look into some theory here, if we have an equation y equals kx to the power of n, we can work out the gradient of this by taking the differential by doing something like this. We call it dy by dx, and this becomes, to take a differential of this, all we simply do is we bring down the power. Okay, we bring down the power and we multiply it by the constant, k being the constant there, and we reduce the original power by 1. So this will become n minus 1. So simply all we have to do here, so now that we know this, so now that we know the fundamentals of differentiation, okay, all we now have to do is we take the original equation, which is our equivalent to y, and we simply differentiate it. So let's do that. So, and that should give us the gradient. So if we do this, y, or let's use the term that they have given us, f of x equals e to the 2x plus 1 minus 3. If you do the differential of that, this is, by the way, this is another way to write first differential. So you see this little colon, little apostrophe mark that you may see that this is equivalent. This is equivalent to the dy by dx. Okay, so this is just another notation for writing. Okay, so how do you differentiate this? Well, the easy way to differentiate this is simply look at what's constant, what is not. So to differentiate an exponential, okay, to differentiate an exponential, remember an exponential is effectively a constant, okay? But we do have a variable in place, which is the x here. So to differentiate this, what we actually have to do is we have to differentiate the power, okay? So the differential of that power being brought down will become 2e to the 2x plus 1. So the power in fact stays the same when we have a differential, okay? But we just bring down what you would have differentiated if it was, let's pretend this was, what you would have done is if you had 2x plus 1 and you were to differentiate this, you would have got 2 left on its own. Remember, when you differentiate a constant, it goes to 0. But when you differentiate a variable, which has got power 1 here, this would have become 2x to the 0, which is the same as 2. Okay? So ultimately, when you're differentiating an exponential, you differentiate the power, and whatever the result of that would have been, you multiply it by the exponential. So that's a quick rule, additional rule that you need to know whilst you're differentiating exponentials. Okay, what happens to the 3? Well, as I've just mentioned, this is a constant, and this will ultimately go to 0. So we've got our generic form of the exponential being differentiated. Now simply all we have to do now is plug in our x value, which we had from here. So x here we can see is 0. Remember, x is the first coordinate. So if you put that in, differential of x, where x is 0, alright, and then gives you 2e to the power of 2 times 0 plus the 1. What does that give you? Well, that simply gives us 2e, right? Because 2 times 0 is 0. 0 add 1 is e to the power of 1. So that just leaves us with 2e. So this is telling us that dy by dx, so the gradient is simply 2e. So this is the question, however, is asking us for the equation of the tangent. Okay, it is asking us for the equation of the tangent. So if we want to work out an equation of the tangent, remember a tangent is a straight line, and if we recall, an equation for a tangent is equation for a straight line is y equals mx plus c. Okay, and if we were to quickly label these, okay, the y is the y coordinates that lie on the line. All right, so we don't need to fill this in because there are multiple coordinates that you can have. This m is the gradient. We used the symbol earlier on. X is the x coordinate. Again, we don't need to fill this in. Coordinates. I'm just going to scribble there. And c is the y-intercept. Okay, so really and truly, we only need 2 of these 4 points. Okay, we need the m and we need the c for us to have a full equation of a straight line. Well, we already have the m from the gradient over here. Okay, we already have the m. So all we now need to do is plug in the y and the x value. Why can we plug them in? Well, the reason is those 2 points, or this 1 point, the x and the y coordinate over here, actually lie on the line. So any point that lies on the line, can be substituted into the equation of that line. So our generic equation is y equals mx plus c. So if we put in our x and all of these points, so let's say m is 2e, our x is 0, I believe the y is e minus 3, and therefore we'll have the one unknown, which is c. So 0 times 2e is obviously 0, therefore it leaves us with c is equal to e minus 3. Okay, so now we're on to y equals mx plus c, and this is given to us in this form now, yeah? So y, remember, we don't need to put the y in, but we know that m was 2e, we know that this will be x, and we know that c is now e minus 3. And there you go, that is how you do logarithms and differentiation. This is how you do exponentials and differentiation, and how you may find a tangent to a curve in an exponential question. Okay, let me know if that's useful, and thank you for listening.